Lesson 19.3, Task 3. Graph quadratic functions in intercept form. You can identify key characteristics of the graph of a quadratic function when it's written in intercept form. F of x equals a times x minus x1 times x minus x2. The values of x1 and x2 are the x-intercepts of the graph of the function. The axis of symmetry is halfway between x1 and x2. So the axis of symmetry is x equals x1 plus x2 divided by 2. So this is just your average. This is how you find the average. You take two things, you add it up and divide by 2. So to find the axis of symmetry, you're finding the average of these 2 points. All right, and you can see that that does lie halfway between your intercepts. All right, so your x1 and your x2 are your two intercepts, and they're showing you how to find the axis of symmetry here. All right, so it says graph f of x equals x squared plus 8x plus 12. So they're giving you an example to look at. So you can take this and rewrite it in factored form, which again is considered intercept form here. So if we factor this expression, we have to find out what multiplies to give us 12 and adds to give us 8. 6 times 2 multiplies to give us 12 and adds to give us 8. So they rewrote this in factored form or intercept form, and then we can look at how to write that so that we can see our x1 and x2. All right, so if you rewrite that, x plus 6 can be written as x minus negative 6, and x plus 2 can be written as x minus negative 2. So that tells you that your intercepts is negative 6 and negative 2. Remember when we were solving for a quadratic equation using factoring, we used something similar to this. So if we had y equals x plus 6 and x plus 2, to find the zeros or the solution, we did x plus 6 equals 0 and x plus 2 equals 0. And we just solved for our two x's. So the x-intercepts or the zeros are the same thing. So written in intercept form, that's just another way to evaluate or see these zeros. So right here where they're saying write this as x minus negative 6, that's just allowing you to see this in this expression here. And then negative 2 the same way. So because x1 is negative 6 and x2 is negative 2, so that means our two x-intercepts are here. The x-intercepts occur at negative 6, 0 and negative 2, 0. What is another method for finding the x-intercepts? All right, so you can set the function equal to 0 and solve for x. So you can do that using a quadratic formula, completing the square, factoring. There are multiple ways to do that with a quadratic equation. But you do have to set it equal to 0 and then solve for x. All right, identify the axis of symmetry. Again, the axis of symmetry is found by averaging the two intercepts. So negative 6 plus negative 2, that's negative 8 divided by 2 is negative 4. So our x value, or y equals negative 4, is going to be our axis of symmetry. Identify the vertex. So the vertex can be found by taking your x, your axis of symmetry, plugging it into the original equation and finding the y value. So it says y is the x-coordinate of the vertex negative 4. Select the correct equation or value to complete the sentence. Well, the vertex lies on the axis of symmetry. So x equals negative 4 is the axis of symmetry, but it's also your x-coordinate of the vertex. So the x-coordinate of the vertex is negative 4. Those will always be the same. All right, again, the y-coordinate can be found by plugging negative 4 into your original equation. So you're going to do negative 4 squared plus 8 times negative 4 plus 12, and when you evaluate that, you get negative 4. So the vertex is negative 4, negative 4. How is the y-coordinate found? Find the average of the x-coordinates, evaluate the function using the x-coordinate, set the function equal to the x-coordinate. So to evaluate it means to plug it in and solve. So that's the way that you find it. Graph the function. So we had two x-intercepts. We can put those 2 points on here. Once you find the axis of symmetry, that gives you 3 points. And then you just sketch the curve between those 3 points. All right, we can identify that A would be positive. We know that our x and intercepts are here and our axis of symmetry, so there's lots of key characteristics that you can see once you draw the graph. All right, that's all for task 3. If you have any questions, let me know. Lesson 19.3, task 4. Choose an appropriate form of a quadratic function. Ayana dives from a diving board into a pool. Her height h in feet above the surface of the water is a function of time t in seconds after she starts her dive. 3 different forms of this function are given. How long is Ayana above the surface of the water during the dive? And what is Ayana's maximum height during her dive? All right, so because this says choose an appropriate form, we're going to look at the different forms that we've studied. So we've studied standard form. We recently studied intercept form. That's what we've been learning in this lesson. And in the previous lesson, we learned vertex form. These are 3 equivalent equations, just written in a different form. So all 3 of these represent her path as she goes off the diving board and hits the water. So again, what we want to do is see how long she's above the surface of the water and what her maximum height was for her dive. So to determine how long Ayana is above the water, Ayana enters the water at a height of 0 feet. To find that time, all you have to do is substitute 0 in for h of t. So substitute 0 in for y, and then find the zeros. So the easiest way to do that is to use standard form. So if you substitute 0 in here and here, you could easily, substitute 0 in for h of t, and then you could find what you needed very quickly and easily. All right, so it says to find the zeros of the function, use the function written in intercept form. So what they did was they took the standard form, they rewrote it in intercept form, and to find the zeros, this would be -1 and +2. Remember, from factored form or intercept form, you can easily find the zeros. And since we're looking at when she hits the water, which is at height 0, that's why we plug in 0 for that function. All right, so it says, what does t equals 2 represent? Remember, t is time in seconds. So it says the height of the board in feet. No, the time in seconds after she dives when she enters the water, the horizontal distance. So it's going to be the time because t equals time here. All right, so the zeros are -1 and 2. Ayana is above the surface of the water for 2 seconds. Why is the 0 t equals -1 ignored? All right, so again, we're talking about time. So the distance from the diving board is positive. The distance, so we're not talking about distance here. So t equals -1 represents the time, that's true, in seconds. So it would be before she dove. So that would be the correct statement here. So that represents about 1 second before she took off for her dive. Determine the maximum height. Okay, so this would be best found from vertex form. So it says Ayana's maximum height during her dive is at the vertex of the graph. To find the vertex of the graph, use the function written in vertex form. So we can see that 0.536 is your vertex. Ayana's maximum height during her dive is 36 feet. All right, so it says, what does the vertex of the graph represent in this situation? Well, it represents after a half a second, she's 36 feet above the water. So that's what it represents in this situation. So that is all for task 4. If you have any questions, let me know.